All right, so I'm going to go over all of the study guide, part 1 and part 2. Naming each solid. Well, the ones that have a tipping point are pyramids. So, and it's based on the base, so rectangular pyramid, pentagonal pyramid. This one obviously is not called a circular pyramid, it's just called a cone. The other ones are prisms. Now, it's very important that when you have a prism, when you're naming the prism, it's important that you find whatever you have two of and they're parallel to each other. So in this case, you have two triangle bases that are parallel to each other and they form that right angle. So this becomes your base shape, and then this is your height. Same thing from here. Even if it was laying this way, this is still your height because that is the distance from one base to the other base. So this would be a hexagonal prism. All right, and then again, faces, edges, and vertices. Well, the faces are going to be all of these sides right here. The edges are just going to be these, and count them up. And then, of course, the vertices are just the corners. There's a formula for that, but I'm just going to let you guys count those. Okay. Okay, so for the next one, we have a pyramid, and which one is shorter? So here we have 3 rulers that are the same length. Oh, it's hard to see. Okay, there you go. If you stand this up, we know that this is the same height. As soon as I slant this, that is not actually going to be the same height. It's going to be off a little bit. So this height, in order for that to actually connect, the slant height actually always has to be higher than, so the slant height is longer than an actual perpendicular height, okay? The shortest distance, well, it's just because it's a perpendicular that would make it a shorter height. So perpendicular height is going to be shorter than the slant height. Slant height is going to be a little bit longer than this one. All right, next one, find the slant height of the pyramid. Same idea. Make sure that you understand how to see this. This triangle, the slant height, is actually not the same as this edge height right here. Okay, and sometimes that's kind of hard to see. So what you're going to do is you're going to see this height, which is 6. This 3.5 is half of here because it's the center. And then you're just going to do Pythagorean theorem, and that's going to be your slant height. And again, the variable that they're using in the book for slant height is a cursive L. So when you have your formula page and you see equations like this, that means it's the slant height that they're using. Find the height of the pyramid, same problem, except they're just asking you for this height. So you're still going to draw a right triangle inside of that pyramid. So slant height is 30. This, of course, is half of 36 from here. So that's 18. And then Pythagorean theorem, whatever that is. Okay. Volume of the hemisphere. Well, here's the formula for the volume of a sphere. And again, make sure you have this handy with you. So volume of a sphere is here. Make sure you write the formula correct. It's 4/3 pi r cubed. So your radius is 3. Easy, just plug that in. So it's 4/3 pi r cubed. Because it's a hemisphere, we're going to divide it by 2. Plug it into your calculator and whatever that is. Okay, surface area. Surface area is going to be a little bit trickier. Surface area. All right, surface or volume is easy. You just take the formula, divide it by 2. Surface area is a little bit more complicated. Surface area, if you have an orange or a sphere and you were to cut it in half, when you cut it in half, all of a sudden you now have another surface that you added. So you actually have to find the surface area of this. Well, that's 4 pi r squared divided by 2, but then you have to add the new surface, which is just a circle. So then we have the surface area for a sphere is 4 pi r squared. Again, I'm going to take half of that just to get the outside. So 4 pi r squared divided by 2. And then the area of the extra surface, the inside of that sphere that we cut, is just a circle. Plug in your radius and whatever that turns out to be. A short way of saying that is if you take this by 2, you divide this by 2, you get pi r squared, and then you're going to add another circle. Well, that turns out to be 3 pi r squared. And yes, that always works. And plug in your radius into that again. Okay. Now your answers, if you're not getting the same answers as me, you could be wrong, or you could just have a rounding error. So for example, if I plugged in 27 pi into my calculator, I'm going to get, let me get this to focus. It's 84.82. But if I plugged in 27 times 3.14, I get 84.78. So if you're off a little bit sometimes, it's a rounding error, okay? If you're off by a big number, that means it's just wrong, okay? So be careful with that. If you want to pause it and just check over your answers, or otherwise I'll keep going. Okay, so for this next problem, what we have is finding the volume and the surface area of this right rectangular prism. So the volume formula is here. And first thing we have to do is volume is going to be area of base times the height. Where is your base? Remember, your base is whatever you have two of and they're parallel to each other. So in this case, your base is this triangle here and this triangle here. It is not the 12 by 10 rectangle down at the bottom. So your base is this triangle here. So you're going to calculate it. Base times height. So that height is 16 times 12 divided by 2. And then you're going to multiply it by the height. Well, the height is a distance from your two bases. So the height is 10. Plug that into your calculator, and we have it right here. So it's 960 centimeters cubed. Surface area. Surface area, if you use the formula, it says it's 2 times the area of your base. So area of the base, we figured that out right here. So 2 times 96 times the perimeter of the base. Perimeter of the base is all of this right here. 16 plus 12 plus 20, 48 times the height of the prism, and height of the prism is 10. You're just going to plug that straight into your formula. The problem that students miss with this part is that they get the wrong numbers here, or they say, oh, this is the perimeter, you know, down here. No, make sure you know it's like the area of the base, the perimeter of the base. The height isn't 16. The height is from one base to the other base. Okay, so that's where students tend to get that wrong. If you're not using the formula for the surface area, then you're doing it this way, which is a lot longer, and that's actually the way that I do it. I just add up all the pieces. I say, oh, okay, well, I have this back face right here. That was 96. And I have the same one up here, so that's 96. I have this back side right here, so that's a 16 by 10, 160. Then I have the bottom, 120. And then I have this slanted side right here. That's a 10 by 20, 200. Add all these numbers together. Okay? All right, whichever you prefer. This problem here is almost the same as this, but it's actually a little bit harder. The reason is because this problem here, you had a right triangle, and finding the area of a right triangle is easier. This one, it's an equilateral triangle, so there's actually a formula for it that's not on your paper. So if you want to add this, formula for an equilateral triangle is the side squared times the square root of 3 over 4. So if I just plug in 3, I get 9 squared root of 3 over 4. Plug it in, simplifying, and I get this for the area of an equilateral triangle. If you're not using that formula, then what you're going to do is you're going to create a right triangle, and you have to find the height. So this distance right here is 1.5. Slant height is 3. Pythagorean theorem. And you get that your height was about 2.6. So now you're going to find the area of that triangle. So the base was 3, height was 2.6. So base times height divided by 2, and whatever that is, 3.9. So now the volume is going to be area of your base times the height, 3.9. And again, the height is the distance between the two bases. So your height is 10 and its volume, so it's 39 meters cubed. All right, so this is now the second part of your study guide, and same thing, you just want to have your formula sheet handy with you. So first one is volume of this. Volume is going to be the area of your base times the height. Well, area of the base is pi r squared. So I got about 95, so 95, and the height is the distance from one base to the other base, which is 16. And there's your answer. Surface area. Surface area is actually just this formula. Now you could have it, well, you don't need to memorize it because you actually have your formula sheet. So surface area is right there. I actually don't have it memorized. I just recreate it. I know that the surface area is going to be the top and bottom circles. So that's 2 circles. So that's 2 pi r squared. And then this horizontal side, let me get the sides of a cylinder. If you had this cylinder, you know that of course your base is a circle and another circle. So that's this part. But the side, how do you add that up? Well, it's just going to be a rectangle. So how do you find the area of a rectangle? Oh, that's easy. That's this. Well, that's actually the circumference of your circle. What's formula for circumference? 2 pi r. And then what's this? Oh, that was the height of our cylinder. And so that's how they came up with this formula. So you can use your formula sheet or just think about it. That one's not too bad. So, and then you just plug everything in. The only thing you need to know is your radius. Be careful because sometimes they give you the radius in the picture and sometimes they just give you the diameter. So in this case, 11 is referring to the diameter. And so the radius is 5.5, and you're just going to plug that in. Surface area. All right, surface area for this is 2 ways to do this. You can actually think about it, and you just add up the bottom base, find a triangle side, and then just multiply that by 4. Or you can use the formula. But before you even get started, what you need to know is your slant height. Well, the height is 14. They tell you that the height is 14. That's this distance, and they said it's 14. This whole length is 6. So if you split it in half, it's 3. And then slant height, again, they're using the letter L. So then you're just going to do Pythagorean theorem, 14 squared plus 3 squared equals c squared, or you could use that cursive L. So your slant height is just a little bit bigger than your height, 14.3. So what you do is you find the area of this triangle. So 14.3 is your height times the base 6 divided by 2. You're going to multiply it by 4 triangles. And then you're going to add the base, and the base was a 6 by 6. Can't see that part. The base was a 6 by 6 square, so you get about 208 centimeters squared. I think most of you are probably just going to go straight to the formula, so let me go over that. All right, so here's the formula for the surface area of a pyramid. All right, there it is. Copied it down. 1/2 perimeter of your base. Perimeter of your base is all the way 6 plus 6 plus 6 plus 6, 24. That L is going to be your slant height. We already calculated it at 14.3. You could have also left it as square root of 205. It'll be a little bit more exact. And then the area of the base, okay, which was 36. Put it all together and we get your answer. Okay, this problem is the only problem where I always use the formula that they give you. And let me go over why. Okay, in a cylinder, you could use the formula or just think about it, because when you undo it, the surface area, it turns out to be a rectangle. Easy. I know how to find the area of a rectangle. And two circles. Easy. When you talk about the surface area of a cone, the surface area of a cone, when you undo it, what shape does that turn into? Okay, well, it turns into a circle, and then this is not exactly half a circle. It's a little bit less. So that's why we actually have to use a formula for this one. So when you have a cone, you do have to use the formula. All right, and we're doing volume and surface area. So volume is right there, and surface area is right here. And this stands for lateral area, which would be all of this without your base, okay? And then surface area, of course, is everything. So it's this, and it includes your base. So because I'm going straight to formulas, I just need to know what variable and information I need. So for the volume, all I need is the radius, got it, 5. Need the height, got it, 8. Plug it in, and there's your answer. Okay, surface area. Surface area, wrote it down. I need to know the radius, got it, it is 5. Ooh, the slant height. I don't know the slant height. So what you have to do is you have to do Pythagorean theorem. That's 8, 5, slant height. Figure that out. So your slant height is 9.4 from Pythagorean theorem, plus pi, your radius is 5 squared. Plug it into your calculator. You could just plug this straight in and simplify. Sometimes they like to combine this and leave it in terms of pi. All of our answers have been decimals, but sometimes they'll say, oh, just leave in terms of pi. So that means just combine this and leave it with the pi. And again, if you're plugging it into your calculator with pi or with 3.14, you might have a rounding error, but that's still correct. Okay, this problem is actually a little bit more difficult. Finding the area of the area of the base. The area of the base is a hexagon, and on your formula sheet, to find the area of any regular polygon, regular means that all the sides are the same. It's 1/2 your apothem times the perimeter of your base. So 1/2 your apothem times the perimeter of your base. Your apothem is the distance from the center to the midpoint of the side. So if I have this right here, I have to calculate it. It turns out that a hexagon is actually special because of the way the angles turn out. The interior angles, if you remember the formula, you can look back at your notes or just know that the angle for a hexagon is 120 degrees. It's the number of sides minus 2. So 4 times 180, that's 720 degrees divided by 6. So each interior angle is 120. That means that when I cut this angle in half right here, that angle is 60. Also, the central angles. Well, the central angles are 360 degrees divided by 60. So 360 degrees divided by 6. So that means every central angle is 60 degrees. So now you have a 60, 60, 60 triangle. You can either use the formula for an equilateral triangle to find this area, or you can also use the 30, 60, 90 triangle. And this says, wait, if this is a 30, 60, 90 triangle, this side is 5 because we split it in half. Then this side is 10 on here. And then this side is 5 square root of 3. So your apothem is 5 square root of 3. So plug that in. Perimeter of your base is 10 times 6, 60. And there you have it. That's probably the easiest one. I would probably maybe use this if you know it's an equilateral triangle. It's the side squared. So that's 10 squared, 100 times the square root of 3 divided by 4. And that gives you the area of one equilateral triangle, and then you multiply that by 6 for all the 6 triangles here. Or you could have just found the area of one of these triangles. Base is 10, height is 5 square root of 3 multiplied by 6, and you get this. Okay, it doesn't matter, but either way, you just find the area of your base. Once you have the area of your base, the rest of the problem is easy. So once we do area of your base to find the volume, well, volume is 1/3 area of your base times the height. The area of the base was 259. The height is, oh, we have to calculate the height. So the height in this case, we know this is 5 square root of 3. The slant height is 18. Quickly do Pythagorean theorem, and we get our height is about 15.7. So we're just going to go ahead and multiply that out. Okay. Surface area. Surface area, you can have the formula, which I think is what you guys are going to go to. You like that the most. 1/2 perimeter of your base, so that's 60. Slant height, we already calculated over here, is 18, and area of the base, we already figured out was 259. Plug it in and you get your answer. The other way to do it is just to think about it. You're going to be adding the base, which is 259, and then you're going to find one triangle side. Well, we know that the triangle side right here, the base is 10, the height is 18, divided by 2, and then multiply it by the 6 triangles that you have. So then you have 540 plus your area of your base, and that gives you the complete answer. Okay, I hope that makes sense. That's probably the hardest one on your. All right, now this problem you don't have a formula for, so you actually just have to, you can do it different ways, but I just decided it's easier if I just add up all the pieces. So for surface area, I'm going to try to add up all the faces. So this one I have right here is a 20 by 35, and then I have the front and the back side. So that's 700 times 2, 1400. Then I have these two side pieces, which are the same, and that is a 10 by 20. So 200 times 2, that's 400. Then I have this triangle right here. Well, this triangle right here, the base is 35. So 35 times 20 divided by 2, 350. But then I have the one on the back side, so 700. Here I have this slant, and this is the part that if you got the wrong answer, it's right here. This side is not the same as this. So this roof is offset a little bit. They are not they're not perfect. They're offset a little bit. So one is actually longer. This length is 29 and that's 23. So this is a 29 by 10, and this side is a 23 by 10. 230. And then don't forget, we have the base down at the bottom, the underside. So that's a 35 by 10. I'm going to take all these numbers, add them up, and there, that should be my answer. All right. Number 14, that was actually the same exact problem from section 8.3 homework. So volume of a cone, again, straight to formula, 1/3 pi r squared h. The radius was 4, and they gave you the height was 13. Plug it in. Volume for the snow cone, area of your base is a circle, so pi r squared. The radius is, this is 8 centimeters, and that's the diameter, so the radius is 4. So we're going to plug a 4 in here, and then your height is 5. So comparing 251 to 217, if you want less sugar, then I should get the snow cone. All right, that's it.